Welcome back, friends. We have in the past built the enemy's encoder. Now it is time to crack the code that the enemy is using. Remember, by building the encoder, we are in a situation where we have kind of intercepted the enemy's message, which means we, yes, got hold of the enemy's message, but now we got to do some analysis to understand what is it that the enemy is trying to communicate, and that is what we mean by the process of breaking this code. So let's take an example here. Say in my in this particular situation that I have on the screen, maybe this was the message. Always the message starts in Python, and then this was a secret message. Enemy possibly presumably used no change as an encoder, but some shift on the Caesar shift, which we do not know, Caesar cipher. So I am observing this. Now from this, I must figure out what this code is, and that's what we are going to do. That's what we mean by cracking the code. Let's take one more example. Maybe we'll take, yeah, let's take this example. Now in this case, clearly enemy is doing something, you know, I think it's doing middle swap. I'm not sure. But what we are observing is really this. And from here, we got to figure out what is it that enemy was trying to do. Now, while the intent of this process is clear, it helps to think of this a little bit more deeply before we get down to write our code. So let's go back here. What we are trying to do really by cracking the code is to try and figure out two things. One, the kind of transposition that the enemy might have used. Now remember, enemy might have done no change, enemy might have done even odd swap, enemy might have done a reverse, or enemy might have done a swap middle, and it's all equally likely, but we do not know what the enemy has done. Also, we have to figure out the shift that the enemy has used in the Caesar cipher. Now again, this is unknown, but enemy could have used any shift. Now, once we know these two, then we can really figure out what the enemy secret code is. If we'll solve this problem, however, for the time being, we'll assume that the transposition being used is no change, which means in the code, it's equivalent to setting the variable encoder to 0. Now, later on, we are going to generalize this, which means we'll relax this assumption. We will solve this problem for all the possibilities for enemy, but it helps to make, understand what goes on in the code by just putting this limitation in the beginning, right? So this will simplify our code breaking process. Now, what happens when the encoder has been made to 0, which means the plain text is going through the transposition stage with no change? Really, I'm left with a simpler problem because I have a plain text going through a Caesar cipher, and then I'm observing the enemy's secret message. So all I have to do really is to figure out what kind of shift was used in the Caesar cipher. Since I do not know what this shift was, one approach I have in front of me is to just brute force try every possible shift. Now, why is this even sensible? Because remember, Caesar cipher is also its own decoder. If I have used a shift of 10, say the enemy has used a shift of 10, then I have to use a shift of 16 to get back my message. However, I do not know what the enemy has used, so I'm going to try every shift out there until I get the first 6 letters of the message to be coming out as Python. And I can be sure this is correct because I know somehow that first 6 of letters of the cracked code have to be Python, and that will tell me that then I have hit the right shift for the Caesar cipher. So this is the philosophy with which we are going to build the code. Let's go to the code here. Remember, we are observing message enemy, but for the time being, I am going to just fix the encoder to 0. Like I said, we'll soon come back and undo this condition. But for now, let's just get an intuition into the problem. So first we have set encoder to 0. Now here I want to try every possible shift on my message enemy. So what I'm going to do is that I'm going to say for kk in range, say 1 to 26, I am going to say message decode, msg decode is given by Caesar cipher msg enemy and kk. So what we can do is that, just for understanding sake, we can put print, say for example kk and say msg dec. Let's see this working first, and then we'll make a few observations. If I click this button now, so I would have observed this because remember, this is what enemy sent. If I kept trying every possible shift, notice on this particular shift I indeed see a Python, right? And this must be then the secret message because no other shift will give me this. However, this one shift does give me the string Python in the first 6 letters. which means that this is the one that I was after. Now, one thing notice is that KK took values from 1 to 25. That's because I'm using range 126, and in the range function, if you remember, if you go back to that video, you'll notice that the last value is not included. That's why KK went from 1 to 25, and it basically put out whatever Caesar Cipher put decoded for him. But as we saw in this particular level, the message was indeed Python, right? Which means that now I can use a little bit of slicing, and I can say that, okay, look, let me look at the first 6 letters of the message that's been decoded, and then I will know that I have indeed cracked it. So because if, let's say, MSG decode say 0:6:1, remember this is starting from the beginning going until element number 5, so 0, 1, 2, 3, 4, 5 in steps of 1. If this is equal to, say, Python, oh sorry, I've got this wrong here. I have to be very careful on this. This equal to has to be outside. So if this is equal to, say, Python, then I know that the code has been cracked. So I can be proud and say, hey, look, I've cracked your code. Print, say, code cracked, and I can then go and say print the secret code is and I can just maybe give an extra print here and say, okay, print the secret code is print, let's say, MSG decode. Now MSG dec, the secret code is really the last 10 digits of the secret of the decoded message, and hence I can really just use slicing once again and say this. Now remember, this is start of 6, end not stop not provided, which means all the way to the end in steps of 1. This is really slicing in action. So I can say print message decode 6::1, and maybe I can give one more print. So this print will happen only when let's say I could say this one more print here, right? Now let's see this working, and then we'll come back to improve this code a little bit. So if I did this now, this time round, the secret code is ONZ, whatever, ONDDQZP, whatever. And the reason I'm so sure of this is that because at KK of 6, I found Python in the first 6 characters. So really what I'm doing is that I just try every possibility out there. Wherever I get this, the string matching, I know that is the right code. Now, obviously, this code has to be improved a little bit. And also, we've got to build it for the other encoders. We'll do that a little later. But I'll wrap this video up for here. I'll be happy to take any questions from you. But I hope the logic is becoming clearer and it's also interesting. Take care. Thank you so much. Bye-bye.